Space travel is the ultimate frontier of exploration. It has revealed the hidden truths of faraway galaxies, brought us nearer to the stars, and deepened our knowledge of the universe. However, amid the incredible marvels of space, a new mystery has emerged. How does the human brain react when away from Earth's gravity for extended periods? A new study has given us some insights into this mystery, indicating that people who go on long space missions should give their brains enough time to recover after each journey. But what actually happens to the human brain when it's in the zero-gravity environment of space? Let's explore the intriguing field of neuroscience beyond the boundaries of Earth. A group of committed scientists carefully analyzed brain scans of 30 astronauts, taken before and after their trips to space. The discoveries they made, which were published in the highly respected journal Scientific Reports, were truly incredible. The brain scans revealed that the fluid-filled spaces in the astronauts' brains, called brain ventricles, grew larger after their space journeys, especially for those who went on missions lasting at least 6 months. This finding brings up worries about how long it takes for the ventricles to return to their normal size and function properly again. To understand why this occurs, let's look at how gravity affects our bodies. On Earth, gravity helps distribute bodily fluids evenly. However, in space where there is no gravity, these fluids move upwards, causing the brain to shift higher within the skull. This shift leads to the ventricles expanding. According to Rachel Seidler, a professor at the University of Florida who worked on the study, the longer people stayed in space, the bigger their brain ventricles grew. The expansion of the brain's ventricles is the most long-lasting change that occurs in the brain due to space travel. This has significant implications for astronauts who frequently journey into space. Seidler's findings indicate that it takes around 3 years for the brain ventricles to completely return to their normal state after a space mission. However, we still don't know how this phenomenon affects the long-term health and well-being of astronauts. Rachel Seidler states that there is still uncertainty regarding the long-term consequences of this phenomenon on the health and behavioral well-being of space travelers. Although we don't have all the answers to these questions, it's wise to give the brain enough time to recover after traveling in space. The scientists looked at brain scans of astronauts who went on missions of different lengths. They studied those who went on 2-week missions, 6-month missions, and year-long missions. What they found interesting was that the expansion of the brain ventricles seemed to happen at a slower rate after 6 months. Interestingly, when people took a 2-week trip, there was no noticeable difference in the size of their brain ventricles. This is encouraging news for the developing space tourism industry, as it suggests that shorter trips may have only minimal effects on the brain. Seidler then shares her hopeful view that the rate of expansion will stop increasing after 6 months, even though there isn't data available yet for astronauts on missions lasting much longer. Rachel Seidler expressed her satisfaction, noting that the observed changes did not exhibit exponential growth. She emphasized the importance of this finding, considering the future plans of having individuals spending extended periods of time in space. This fascinating study, backed by NASA, has the power to greatly impact decisions about crew travel and mission planning. As humans get closer to traveling to other planets, understanding how space travel affects the human body is incredibly important for research. In addition to the changes we see in the brain, traveling in space has many other effects on the human body. When there is no gravity, which is called microgravity, it causes the face to swell, the loss of bone and muscle mass, and changes in the cardiovascular system. In space, astronauts face a number of challenges that can affect their health. They can experience a loss of bone and muscle mass, similar to osteoporosis, because of the low gravity. The heart also undergoes changes, becoming smaller because it doesn't have to work as hard. This can cause problems when astronauts return to Earth, like feeling dizzy or even fainting. Another concern is the higher levels of radiation in space compared to what we encounter on Earth. Astronauts are exposed to more than 10 times the normal radiation dose, which increases their risk of developing cancer and may affect their nervous system in unknown ways. The psychological impact of space travel is also significant. Astronauts can feel isolated and confined, and their sleep patterns are disrupted. Living in a controlled environment can lead to emotional and behavioral issues. Some astronauts also experience changes in their vision, possibly due to the low gravity and increased carbon dioxide levels on the International Space Station. Additionally, space travel can cause kidney stones, a vision problem known as visual impairment intracranial pressure syndrome, immune system issues, and difficulties with balance and coordination when returning to Earth. These health concerns make it challenging to provide advanced medical care during space missions, where emergencies can happen. That's it for today. Thanks for tuning in to Cosmic Mysteries. Remember to smash that like button, hit the subscribe button, and ring the notification bell so you never miss out on our mind-blowing adventures into the depths of our planet and beyond. Stay tuned for more captivating explorations coming your way. Until next time, keep exploring and keep your curiosity alive.